Now, in this video, I am going to explain some more points. So, children, so far you have seen about the discovery of electrons. Electrons means the cathode rays. You have also seen the discovery of protons, that is the canal rays or anode rays. So, till now, you know that atoms are electrically neutral, and because an atom have equal number of electrons and protons, and so they neutralize each other's effect, and as a result, atoms are electrically neutral. But you must be knowing from your junior class ninth, that uh, the atoms nucleus have some particles other than the protons. And actually, this I am referring with the discovery of neutrons. Actually, up to 1920, there was no concept of the neutrons. But in 1920, there was scientist James Chadwick. James Chadwick proposed that in an atom there is some neutral particle. Atom, there is a neutral particle having mass equal to proton but have no charge. So James Chadwick said that in the nucleus there are some neutral particles having mass equal to protons, and it is responsible for the atomic mass. So atomic mass or atomic weight A. Atomic mass or atomic weight A. This A is the atomic mass, so it is equal to the protons and neutrons number. This is A. A is atomic mass, and you also know Z. Z is equal to electron or proton. And what is Z? Z is atomic number. Z is atomic number. So this is there. And children, he said that neutrons have mass equal to protons. Mass of neutron is equal to mass of proton, and the mass of proton was exactly equal to mass of proton, and neutron they are same, and so it was regarded as 1 AMU, and it is 1.675 in 10 to the power minus 24 grams. So this is about the neutrons. Then you will see about the very important topic, it is radioactivity, and see how. Now I am going to explain about the next very important part, radioactivity. And so children, radioactivity, it was given by Henry Becquerel. Henry Becquerel, a French scientist in 1896, and he said the property of radioactivity, and he said that some radioactive substances emit some invisible radiations. And actually, the idea of Henry Becquerel was not his own, but actually it was influenced by some scientists, his predecessors, who have worked on this, like J.J. Thomson and the similar Goldstein. And actually, he said that radioactivity is the spontaneous a spontaneous emission of invisible rays from radioactive radioactive elements. So it is a spontaneous emission. A spontaneous means at once, at random. And this radioactivity, it is the phenomenon of emission of invisible rays spontaneously on their own. Now radioactivity, it is the inherent property, means it is associated with a particular radioactive element. And radioactive elements like plutonium, uranium, thorium, So like example, uranium, thorium, polonium, etc. There are many radioactive elements. So he had taken a lead piece. Here there is a lead block. And why he had taken lead block? Because lead is very heavy metal, children. Lead is very heavy metal, and lead has a capacity to absorb the rays. And in the center there was a small hole. A small hole was in the center, and here he had placed a small amount of polonium. Polonium was placed, and he created electric field. He placed photographic film to record his observations. And so see, now children, see, here I have drawn the experiment which was performed by Henry Becquerel. So he had taken a piece of lead. Lead is a metal. Its sign is Pb. Its symbol is Pb. And so lead was taken. So point is, why lead was taken? Actually, children, lead is very heavy metal, and it has capacity to absorb all the energetic radiations. Actually, radioactivity is very dangerous process. Radioactive materials, you all must be knowing, uranium, neptunium, plutonium, all the this elements, they are highly dangerous. They are deadly poisonous because the rays emitted by them, they cause cancer. They are able to cause the mutation in the DNA, in the genes, etc. So that is other point. Now see, he had placed a small amount of polonium. Polonium is this radioactive metal, and it was discovered by Madame Curie. And so he had placed this plate. He has actually created electric field around the experimental setup. So on one side here I have drawn positive, here on the negative. And so he has placed the photographic plate at the front and back to have picturized the representation of the diagram, this rays. And so see here, I have drawn at par with the observation. So he noticed that the rays emitted thereof three different character. The rays emitted by the polonium are of three different character. And so the rays which are attracted towards the positive plate, they travel more height. The rays which are attracted by the or deflected towards the positive plate, they have traveled more height. The rays which are attracted toward the negative plate, they have traveled less. But the third one is, it has traveled in a straight line, neither negative nor positive. So children, he named the rays. So the positively charged particle, positively charged particle he named positively charged particles, they are attracted toward the negative plate. So he named as alpha rays, alpha rays. alpha rays, and alpha rays are nothing but the helium nucleus having 2 unit positive charge. So alpha rays, just symbol alpha. Then coming to negatively charged particles, negatively charged particle, he named beta rays, beta rays, beta rays. And so beta rays are nothing but the electrons, fast moving electrons, and the neutral rays, neutral, that is the rays which are neutral. So he named them gamma rays, gamma, gamma rays. And so see, the helium nucleus, it is positively charged. It is positively charged helium nucleus, and so it is alpha rays. Then beta rays, they are nothing but they are the electrons. Beta rays are nothing but the electrons, and gamma rays, actually they are nothing but they are the fast moving neutrons. They are fast moving neutrons. So the discovery of reactivity, it was able to draw attention of the scientists, and it was a milestone. It was a milestone in the atomic structure. And these rays were initially called as becquerel rays. Alpha, beta, and gamma, they were initially, to honor the Henry Becquerel, they were called as becquerel rays. So this is all about the radioactivity.